We're in our second video for Chapter 11 of Polynomial Functions, and this is Polynomial Factors and Division 11.1b. If you didn't see 11.1a, that one video before this one, you can click on the description, and there'll be a link there. Now, back in Chapter 6 in Video 6.5, we learned about synthetic division, and synthetic division is only used when the divisor is a linear factor, and we can determine whether one polynomial is a factor of another polynomial by division. When we divide one polynomial by another, we get a quotient and a remainder. And if the remainder is 0, then the divisor is a factor of the dividend. I'll explain this a little bit more in a second. So here's our first example. We can divide to determine whether x squared plus 3 is a factor of the polynomial x to the third minus x squared plus 5x minus 4. We use polynomial long division. We learned that in video 6.4b, and I'll have a link to that one too in this description. So here's our divisor, here's our dividend, and what we do is we ask ourselves, we have this x squared, we take this first term x squared, and we ask ourselves, what times this x squared will give us x to the third? Well, x will. We multiply these two together and we get x to the third. We multiply the second term to the x and we get 3x, and we put it in the correct exponential column. This is 3x to the first power, so it goes in the column with the 5x, not x squared, see? We do our subtraction and we drop down our numbers. We get negative x squared plus 2x minus 4. We ask ourselves, x squared times what gives us a negative x squared? Well, a negative 1. We multiply them together and get our negative x squared. And we multiply 3 to that negative 1 and get a negative 3, and we put it in its correct column with the constants. We do our subtraction and get 2x minus 1 as our remainder. Now, because this remainder is not 0, it's 2x minus 1, we know that x squared plus 3 is not a factor of the polynomial. So look at it this way. If we've got 13 divided by 2, 2 goes into 13 6 times, 2 times 6 is 12, we do our subtraction and get a 1. Now, because it's got a 1 remainder, we know 2 is not a factor of 13. Well, 13 is actually a prime number, isn't it? But if we do 2 goes into 12 6 times, and we multiply it and subtract and get a 0 remainder, we know that 2 is a factor of 12. We know that the 2 times 6 is going to give us the 12. The divisor times the quotient plus the remainder is going to give us our dividend. See? Now, we can divide to determine whether x minus 3 is a factor of the polynomial x to the fourth minus 3x to the third minus x plus 3. We can use synthetic division. That's no variables. That's the one we learned in 6.5. So we rewrite it with no variables. So there's really an invisible 1 in front of that x, isn't there? And there's 1 in front of that x. So we can rewrite it as 1x to the fourth minus 3x to the third plus 0x squared. Because there's no x squared, we can put a 0 as a placeholder. Minus that 1x plus 3. Now with no variables, we get a 1 minus 3 plus 0 minus 1 plus 3. And 3 is our divisor. We have no variables, so we're just going to see how many times 3 can go into this. What we do is we drop down our 1, and we say 3 times that 1 is 3, and we add it to this one. So see how we've got them all written here without the variables? So now, negative 3 plus 3 is a 0. Now we've got a 1 and a 0 so far for our quotient. Now what we do is 3 times that 0, and we add it to this column. That gives us a 0. Now we do 3 times 0 and add it to this column. We get a negative 1. Now we do 3 times the negative 1 and add it to this one, and we get a 0. So our quotient is a 1 plus 0 minus 1 with a remainder of 0. We got a remainder of 0, just like we did with the 2, the 12, and the 6. So this 1, 0, 0, negative 1 with a remainder of 0, this is our constant, negative 1. This is our x. This is our x to the second power. This is our x to the third power. So that would give us a 1 x to the third power plus a 0x squared plus a 0x minus 1. See? We don't need to write these 0 ones, do we? So we just have x to the third minus 1 as our quotient. Now, because the remainder is 0, we know that x minus 3 is a factor of the polynomial. And if we multiply x minus 3, the divisor times x to the third minus 1, our quotient, we're going to get our polynomial. Just like if we multiplied 2 times our quotient 6, we'd get our 12. right? Now, when you get really good at synthetic division, it'll look like this. You can go really quick. You just do 3 times 1 is 3. You do your subtraction. Then you do 3 times 0 is 0. You do your subtraction. You do 3 times that 0 is 0. You do your subtraction. And then you do the next one. 3 times the negative 1 is a negative 3. And you can go really quick when you are good at synthetic division, okay? It won't look as long as mine did with all of this explanation, all right? You'll just be able to do it real quick like that. Now, when we divide a polynomial p of x by a divisor d of x, we get a polynomial q of x for a quotient and a polynomial r of x for a remainder. And that remainder must be a 0 or have degrees less than that of the d of x, that divisor d of x. And we can show every polynomial division as p of x equals, that's the dividend, the divisor as d of x times the quotient q of x plus the remainder r of x. Just like we did, 2 times 6 is 12, plus the 0 remainder is 12. So we're going to let p of x equals 5x to the third minus 6x squared plus 18x minus 4. That's going to be our polynomial, and here's going to be our divisor, d of x. It's going to be x squared minus x plus 3. And we can find p of x divided by d of x and then express it as this way, as a divisor times the quotient plus remainder is going to equal that dividend, all right? So we're going to divide. We say x squared times what will give us 5x to the third? Well, 5x. We multiply them together and get 5x to the third. Now we multiply this negative x times the 5x, and we get a negative 5x squared. Now we multiply the 3 to the 5x and get a positive 15x. We do our subtraction, and we've got a negative x squared plus 3x minus 4. We ask ourselves how many times x squared can go into a negative x squared, or you can say it as x squared times what gives us a negative x squared? Well, negative 1. We multiply negative 1 times that x squared and get a negative x squared. We multiply negative x times the negative 1 and get a positive x. We multiply the 3 to the negative 1 and get a negative 3. We do our subtraction and get a 2x minus 1 as our remainder. And the quotient is 5x minus 1 with a remainder of 2x minus 1. Now we can express p of x, that polynomial, as a product of the divisor and the quotient multiplied together plus that remainder. So our polynomial is our divisor times the quotient, 5x minus 1, plus that remainder. That'll equal that polynomial. See? Our next video is 11.2a, and we're going to use synthetic division and the remainder theorem to find p of r. And there's going to be links in this description for the previous video for Chapter 11 and those videos, 6.5 and 6.4b, that talk about synthetic division or long division for polynomials. All right? So I hope this was helpful. I hope I explained it clear enough. I know synthetic division can become very confusing, but you can always click on the description and watch those previous videos back from Chapter 6 to help you out. All right? I'm really proud of you for watching these videos. I'm counting on you to make it through this, and I think you can do it. Bye.